Correct. Right. So now in today's class, we are going to, important for your examination for sure. That is, let me pin myself. Okay. Right. So now, one thing we are going to see here today is like we are going to discuss some of the important concepts. Some of the important concepts basically we have already discussed in the previous classes. Just I want to check whether how many of you have remembered it or not. So for that purpose, we are discussing the questions. Okay. So now I would like to see you how many of you will answer this one. CH3, CH, double bond, CH bond CHO is there. It's a kind of crotonaldehyde. We call it as a crotonaldehyde. Okay, in JEE means that question is asked. So you are converting into CH3, CH2, CH2, OH. So if you are converting the crotonaldehyde into alcohol, what is the reagent, suitable reagent you are using? One is NaBH4 and B lithium aluminum hydride and C okay, H2 in the presence of palladium or nickel, and D, you can also take zinc amalgam in the presence of HCl. I hope you guys understand. So please answer in the chat box. Among the following, which reagent can be used to convert from the aldehyde, enoldehyde, we can also say enol, okay, because a double bond is there and aldehyde is there. So from enol to alcohol, which you are going to use. So now for that one, we already know that LaH, lithium aluminum hydride, can be convert everything like aldehyde, ketone, okay, and carboxylic acids except alkenes. Okay, but it also converts. LaH can also converts what? Resonance consists of alkene. So resonance consists of alkene means individually alkene cannot be reduced by LaH, but LaH can reduce the what? LaH can reduce the this particular question. Okay, so LaH can reduce these kind of compounds because of the resonance involving. Extended resonance is taking place, so this can be reduced by LaH. Other than it will not reduce. Whereas, so NaBH4, we can also call it as sodium borohydrate. So sodium borohydrate, it can only reduce only aldehydes and ketones, but not acid derivatives. So here LaH can also reduce. LaH can also reduce acid derivatives. What are acid derivatives? Like acids and acid derivatives like COOH, okay, and CHO, C double bond O, keto group, ester group, SL halide group. Okay, so these all are going to be reduced by the lithium aluminum hydride, but whereas NaBH4 is a weak reducing agent, so it can reduce only these but not acid and its derivatives, and alkenes also will not undergo. But if you see the H2 in the presence of platinum or palladium or nickel, this is a very strong reducing agent. What is this? Very strong reducing agent. So whenever it is a very strong reducing agent, what we can say from here? We can see from here is this can reduce alkenes, whatever it may be, alkenes also, alkynes also. It can reduce aldehydes, ketones, and the acids and its derivatives. So the answer is H2 in the presence of platinum and palladium. So this question came in AIMS 2010. This question came in AIMS 2010. Okay, so this is some of the important things if people need to remember. Okay, in the previous class, we have discussed about the, okay, in the previous class, we have discussed about the formation of, Reamer-Teamer reaction. Okay, in the previous class, we have discussed about what? In the previous class, we discussed about Reamer-Teamer reaction, that is RTR, Reamer-Teamer reaction. So in the Reamer-Teamer reaction, what is the first thing we have observed? The Reamer-Teamer reaction, we have an alcohol. So this alcohol, under the using of chloroform in the presence of to produce what? Salicylic aldehyde. What you are going to produce? You are going to produce salicylic aldehyde. So this salicylic aldehyde formation can be favor. And among these two, which is favor one? Para product is more stable than ortho product. We have seen this in the previous class. So what is the, this is the Riemann-Tiemann reaction, but in your examination, they will ask, what is the electrophile here? What is the electrophile? Electrophile is dichlorocarbon. What is that? Dichlorocarbon. You are having one lone pair and one vacant orbital and two. So this is also called it as dichlorocarbon. So this is Riemann-Tiemann reaction, which we have seen in the previous classes. Okay. So at KOH, we are doing SN2 mechanism for twice. In the yesterday class, we have already discussed that one. I don't want to go with that one. So next, another prominent reactions are whenever you are reacting with zinc. Whenever you are reacting with zinc, what is the products you are going to get? Let's suppose if you are having benzene, okay, along with OH, which we are going to call it as phenol group. So if you are having a phenol group, if you are treating a metal like zinc also, silver also, whatever it may be, they are going to reduce oxygen. Means like there is a reduction will takes place. What they are going to takes place? There is a reduction. So how the reduction is simply nothing but removal of oxygen. So very simple. You just need to remember here. Very simple. You just need to remember. Okay, so just suppose if you are having, okay, and you are having zinc, just reduce oxygen from here. Just reduce oxygen from here. That is, just remove Z and O from here. Then what you are going to get? You are simply going to get a benzene. You are going to get a benzene here. I hope you guys understand. I hope you guys understand this one. So how do you prepare benzene from phenol? How do you prepare benzene from phenol? By just using a reducing agent, that is zinc, which will help in the reduction of phenols to benzene. Now, next one. What is the next case we have seen here? So the next one is if you are having a oxidation. How do you do the oxidation? Oxidation reaction we are seeing very most important and prominent in our examination, right? Very most important and prominent in our examination. That is phenol. Okay, so phenol under the use of Na2Cr2O7 in the presence of H2SO4 or any strong acid. So what is the product you are going to get? Yes. So this is oxidation. Oxidation is simply nothing but what? Removal of hydrogen and addition of oxygen. What is that? Removal of hydrogen and simultaneously addition of oxygen. Removal of hydrogen and addition of oxygen. So how do you add this one? So here you are just simply going to get compound like this. Okay, I'm so sorry. Here we should not keep zero here. So like resonance hybrid. What is the meaning of it? That is a resonance hybrid. This is called as resonance hybrid. Resonance hybrid. So we should not keep the resonance hybrid here as it involves only like this. So what we are going to call it as para-benzoquinone. What we are going to call it as para-benzoquinone. Simply we can also call it as hydroquinone. We can also call it as what? Hydroquinone. And I told you for the hydroquinone and all, there is no tautomerism will takes place. No tautomerism will be takes place. No tautomerism will takes place. Okay, na? So these are the things we have discussed and very most important for your examination. So let's do one practice question so that we can proceed. Okay, now see here. I just want to see how many of you can do this question. Yesterday I have taught this topic. Okay, so now at meta position you are having one methyl group. Let's suppose if I'm treating with dilute HNO3. So we already know this one. Dilute HNO3 means how the dilute HNO3 will be used. My dear YouTube friends, you people also try. From the dilute HNO3, you are going to get an electrophile called nitronium ion, NO2 plus nitronium ion, which is the electrophile. So because of this, electrophilic substitution reaction will take place. Electrophilic substitution reaction, addition reaction will take place. Now the electrophile will be added here. Now what is the first case you are going to take place here? H plus and NO2 plus. Okay, H plus NO3 minus, from NO3 minus oxygen will be grow. So there are a lot of stories will going to take place. So at the end, the product will be, at the end, the product will be, it will be a ortho, it will be a ortho adding product, and simultaneously we are not doing anything with the meta methyl group. So the position where the methyl group is at the meta position, we know this is ortho position, this is meta position and para position. But why sir NO2 is not attacking here? Many students will have a question, why NO2 is not attacking here? Why in the other side of this one? Why in the opposite side of this one? Because of the hindrance of the OH group, because of the hindrance of OH and CH3 group. Whenever the NO2 plus trying to attack or trying to add in this particular case, so because of the CH3 group, which is a plus I group, and simultaneously OH, which is plus M group, and they are trying to inhibit the attack of the NO2 plus added at the opposite, or we can say opposite at the meta position of CH3. Okay, so this is what the product you people need to remember. And next, phenol, if you take the phenol, and if you are taking methyl carbonyl chloride, what is this? Which is also called it as CH3 C double bond O Cl. Okay, okay, acyl chloride. So what will going to happen in this case? Acyl chloride, what will going to happen here? You are going to get positive charge, and here you are going to get negative charge. Here you are getting negative, positive. Same story. Okay, wahi kahani purani. So you just need to keep O here, and from here C double bond O CH3 will attack here. And again further, if I am treating this with HNO3, okay, in the presence of H2SO4, HNO3 in the presence of H2SO4, the main stable product will be what? The main stable product will be NO2 at para position. Why? Because if you keep NO2 here, there is a intramolecular hydrogen bonding will take place, and usually because of this, you know, the stable position will be para position. So okay, para position will be the major. Para position will always taken as major. Ortho position is taken as minor. So if they are asking for the major one, para, nitro compound is always stable. Okay, I hope you guys are understand. And last today's class, we are going to finish the ethers. So that is ethers concept. Okay, we are finishing the chapter with ethers. So now most of the points you people need to remember is, first thing, what is the first thing we have seen in the ethers? That is dehydration of alcohols. So the preparation of ethers by doing the dehydration. In pre-board also last time there is a question came. So what is the question? Let's suppose if I am having a alcohol CH3, CH2, OH, if I am using concentration H2SO4 under the influence of 413 Kelvin. Okay, if it is 413 Kelvin and next one is 443 Kelvin, you will get an alkene. Okay, if it is 413 Kelvin, you are having what? You are going to get an ether. What you are going to get? You are going to get an ether CH3, CH2O, CH2, CH3. So ether formation will take place at lower temperature for this one. If you are in presence will be takes place. So what is the first mechanism? What is the mechanism we are going to see here? The mechanism is from H2SO4, you are going to get the H plus. So these H plus will try to attack on the oxygen where it consists of lone pair. So this lone pair, where this H plus will come? This H plus will come from H2SO4, H2SO4, H plus, H2SO4 minus. So this H plus will attack on the oxygen. So the product, the intermediate will be formed as CH3, CH2, OH2, positive charge on the oxygen. Now we know that positive charge on oxygen is unstable, and then they will take H2O from here. Then you are going to get CH3, CH2. Okay. So before it leaving, you are going to get a positive charge, but we will take excess of ethyl alcohol. So that is again CH3, CH2, OH will attack on this carbon. So now you are going to get CH3, CH2, whatever the lone pair is there, that lone pair will be given to the oxygen. Again, oxygen will get positive charge. CH2 CH3 as you can see here. आपको समझ में नहीं आया होगा, थोड़ा सा दिमाग लगा दीजिए, ठीक है. So here oxygen is getting positive charge. So here what is going to happen? The shared pair of electron will be taken. Then it will get a carbocation positive will be takes place. So another ethyl alcohol is there. What is that? Another ethyl alcohol is there, which is having a lone pair on the oxygen. So this lone pair will attack on the carbon, and again you are going to form an intermediate like this. Same story. Now the hydrogen which is shared between oxygen and hydrogen will be give these electrons, and it will leads to formation of CH3 CH2 O CH2 CH3. Okay, so this is what the mechanism for the preparation of ethers. Okay, for the preparation of ethers, this is the mechanism. Okay now, so second very most important, Williamson synthesis. What is that? Williamson synthesis. What is that? Williamson synthesis. So Williamson synthesis, what is Williamson synthesis will help for? Tell me, what is the Williamson synthesis will helpful for? Tell me in the chat box, what is the reactant and the reagent in the Williamson synthesis in the chat box. What is the reaction, that is reagent, reactant in the Williamson synthesis? How do you do the synthesis? Tell me in the chat box. At least mention the reactant, so that I feel that you people know this one, because every time I was teaching, but I didn't feel that you people are understanding it. So at least tell me this is the naval reaction and very important for the CBSE. So that's why I was asking to you. Tell me in the chat box. Any school in the from the YouTube also, Ahmednagar, Daman, Warda, KNR. Right. So I know like many people have been confused, it seems. No need to worry about that. Next, R dash X in the presence of RO minus Na plus. In the presence of sodium alkoxide ion, we will doing SN2 mechanism for the production of ether. For the production of ether, not ester, for the production of ether. So how do you this one? For this one, very most prominent and important thing आपको याद होना चाहिए, very most important thing, the alkyl halide, whatever the alkyl halide we are taking, that must and should be a primary one. That should be what? Primary alkyl halide. Why? What will happen if it will become secondary and tertiary? Secondary and tertiary alkyl halides under the influence of the any strong base, what will going to happen? Elimination will take place. Best example, if I am taking CH3Cl in the presence of, let's suppose CH3CH2ONA plus. Okay, what will going to happen here? This is going to, here Na is there, Cl is there, both will go as NaCl, and which is undergo SN2 mechanism. The product formation is CH3O CH2 CH3. So this is the product formation will takes place. Let's suppose if you are having a product like this, CH3 C bond CH3 CH3 and here Cl. Okay, and if you take if you are taking a strong base or weak base, this is usually weak base. Strong base is like tertiary butoxide. This is actually what? Tertiary butoxide. Okay, so strong base if you are taking with a tertiary alkyl halide, then this will undergo which reaction? E2 elimination reaction. So from alkyl halide, what you are going to get? E2 elimination will help in the production of alkene. Alkene produce करती हैं. So definitely tertiary alkyl halide use नहीं करना चाहिए. So what will be the product here? Here E2 base will be takes place, and here Cl will be gone, and after that this is alpha carbon and this is beta, and we know that alpha beta elimination will take place. So what will going to happen here? Here you are going to get one isobutene. Okay, you are going to get isobutene, or in other words, CH3, C double bond CH2, CH3. Okay, isobutene formation will take place in the presence of a strong base. So definitely for the ether formation, what you need to remember, for the preparation of ether, the alkyl must and should be a primary alkyl halide and the base should be a weak base. If you are having a strong base and the compound is a reactant is a tertiary ethyl alcohol, then it will undergo what? E2 elimination, which will help in the production of alkenes. I hope you guys understand this one. Correct. So now let's practice some questions here. Let's some practice here. Let's suppose I will see how many people can answer. A plus B is going to give you anisole. A plus B is going to give you anisole, and you have to find what is A and what is B. The hint is given. This is salt and this is alkyl halide. Alkyl halide they have given already. So the alkyl halide is Rx. Anisole you already know, PHOCH3, that is benzene methoxybenzene. We can also call it as methoxybenzene. Now what will be the salt and what will be the alkyl halide? So let us think about these things. Salt will be, let's suppose salt case and alkyl halide case we will take. Salt, if I am taking sodium phenoxide ion, sodium phenoxide ion, and if I am taking the alkyl halide as CH3X, or else if I am taking CH3ONA, okay, salt is sodium alkoxide ion, and here the alkyl halide is a chlorobenzene. Alkyl halide is a chlorobenzene. So which is the more suitable reactant? Either first set or second set, set 1 and set 2. Tell me in the chat box which is the most suitable set for the production of anisole. Tell me in the chat box, set 1 or set 2 in the chat box, guys. Please do reply in the chat box, set 1 or set 2. Please do reply. Come on, guys. Please do reply in the chat box. Which set is the most suitable one for the preparation of anisole? At least pattar to maro. Try to answer by throwing a stone. Set 1 or set 2 is the most preferable one. I'm not getting any answers. It's okay, fine. So if you see in the set 1 is the most preferable one. Set 2 is not preferable. The reason because the halogen which is present here will undergo plus M group and will get a partial double bond character. Partial double bond character, double bond character will develop. Partial double bond character will develop, which leads to what? Which leads to poor release of CO2. So that is why this is the most suitable one. Sodium phenoxide can easily lose Na plus, and here methyl halide can also undergo. So I already told you SN2 mechanism is favors for methyl halide, then primary halide, then secondary halide. Tertiary will not undergo. If tertiary halide will come, which will take place? E2 elimination will take place under the presence of base. Is it clear to you all? I hope is it clear to you? Simultaneously, I will see another one more question now. So let's see. I just want to see how many people can do it. A plus B gives rise to a product like this. Okay, so this is kind of product. I just want to see how many people can get it. So again, I'm going to give you two sets. Set 1 is okay, and the set 2 is Right. I already told you in the previous classes, I have already told you that, right. Right. So we all first need to keep remember about SN2 mechanism. Here we are having a bridged, group. Okay. And here we are having a methyl halide. So this is most favorable and this is not. Why? Because bridged headed, okay, halogens, bridged headed halogens will not undergo SN2 reaction or SN reactions. SN reaction वो देता नहीं है, bridged headed halogens. Okay, so the only possibility will be the first one, and we already know that methyl halide is a very good, undergo reaction for the SN2 mechanism. Okay, now next we can see from here. Okay, next we can see from here is, okay, properties of ether. We will see the properties of ether. Chemical properties we are looking for ether. Okay, after that, I think our chapter will finish. Okay, 12 minutes left. Chemical properties of what ether we are taking. First one, reaction with HX. Reaction with HX. Okay, how the reaction will take place. Let's suppose if I'm taking an ether, here, okay, which is having a lone pair. And if I am taking in the presence of any reaction, we know that this will get H plus and minus. What is the duty of H plus? H plus will first attack at the oxygen. So what it will going to take place? ROR, and here H will take place, and here you will get a positive charge on the hydrogen. Okay, so then thereafter, what is the case? Now the positive charge on oxygen is unstable. So now it will try to take the electron from, for this, let's suppose this is R dash, right? This is R dash. This is A and B. So there is a shared pair of electron between O and R and O and R dash. O and R and O and R dash. Now how they will take the shared pair of electrons? Which one it will take? Yes. So to take the shared pair of electron, whether from A and B, to take shared pair of electrons, shared pair of electrons can be done by carbocation stability. सर कुछ समझा नहीं, एक बार समझा दीजिए। बिल्कुल। तो लेट सपोज अगर मैं इस तरह का एक रिएक्शन लेता हूं, ठीक है ना, अगर आपका R या R डैश टेरिशरी हो, ठीक है, और वो रेजोनेंस में इन्वॉल्वड हो या रेजोनेंस इन्वॉल्वड हो विथ प्राइमरी एंड सेकेंडरी, ये हो जाता है आपका SN1, और ये डायरेक्टली कौन सा मैकेनिज्म पे जाएगा? SN2 पे जाएगा। सर क्लैरिटी नहीं है, थोड़ा सा क्लैरिटी दे सकते हो? यस, थोड़ा दिमाग लगा दीजिए यहाँ पर, ठीक है, थोड़ा दिमाग लगा दीजिए आप लोग। राइट, तो यहाँ पर मुझे एक पर्टिकुलर एग्जाम देता हूँ, मान लो CH3O CH2 CH3, and now you are attacking with HI. Right, so now we are attacking with the HI. Let's suppose what we are going to happen. What is the first step? First step, H plus will attack on oxygen. Why? Because it consists of lone pair. Okay, H plus will attack on oxygen. Whenever it is attacking on oxygen, what is the primary most thing will happen? CH3O H CH2 CH3. So again you are going to get a positive charge. Now there is a question. Now here also shared pair of electrons are there. Here also shared pair of electrons are there. Now from which carbon will oxygen will take? So this is second one. From which carbon the oxygen will take, so that the carbocation formation should be most stable one. Just imagine from which carbon the oxygen will take, so that the most favorable condition will be the most stable carbocation formation will take place. Right, here H will be attacked and second will be what? I minus will be substituted. I minus will be substituted. How? Where it will substitute? Just imagine. Okay, so let's suppose think you got CH3 plus and you got CH2 CH3 plus. You got, these are the two carbon. Let's suppose पहले 1 से निकाल दिया तो मान के चलेंगे if they are taking from 1 you will get a methyl cation, or else if they are taking from 2 they will get a ethyl cation. Okay, and we know that carbocation with more plus I groups will be unstable because of it is plus I group, so this will be unstable compared to the methyl cation. Methyl cation will be more stable because there is no plus I, there is no minus I group. But ethyl cation is unstable because of the presence of positive group. So what it will do, it will decrease the stability of the carbocation. So the most stable carbocation will be become what? CH3 positive. So this CH3 positive, or we can also say that is ready to act as more electrophile. It requires electrons. So I minus will attack on the methyl cation, not on the ethyl cation. So what will be the product here? CH3I plus. Now, if it is taking from this one, sorry, here I have mentioned wrong. Yeah, so if it is taking from this, bonded pair, okay, you are going to get methyl cation here. So now the methyl cation you are going to get. Now the end product will be methyl cation plus CH3, CH2OH. This is what? Ethyl alcohol. This is what? Ethyl alcohol. And this is what? Methyl halide, methyl iodide. I hope you guys are understand this one. Correct. Right. So this is methyl iodide and next one is ethyl alcohol. Okay, na? Right. So next we can see from this one. Right. How much time left here? Yeah, 5 minutes left. So I will take, so try to answer this question. Then after answer this one, our chapter will be finished. Let's suppose CH3, 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 CH3. If you are attacking with an HX, what is the product you are going to get? What is the product? Same question. First H plus will attack. What is going to happen? H plus will be attacking on the oxygen. So the intermediate product will be CH3OH, positive charge on oxygen, CH3 thrice. Okay, now the question is, here also shared pair is there, here also shared pair is there. From where the oxygen will take place, for where the oxygen will take the electrons, that is the biggest question. If it is taking from this one, you are going to get a methyl cation. But if it is taking from this carbon, you are going to get a tertiary carbocation. What you are going to get? You are going to get a tertiary carbocation. We know this is primary carbocation, not primary. This is methyl cation. And what about this one? This is tertiary cation. And what we have told? If we are having a tertiary carbocation which is more stable, this will be more preferable. So that is why oxygen will take the electrons from number 1 carbon. So it will first form in CH3OH and next X will attack here. The end product will be CH3 taken thrice. CH3 taken thrice. So this is what you are going to get. Okay, I hope you guys understand this one. I hope you guys understand the product here. Okay, now another one, let's suppose PHO, sorry. In your examination, these questions only will come. PH, CH2O, CH3 is there. And if you are having HX here, what is going to happen? H will attack here. So PH, CH2OH, positive charge on oxygen and again CH3. Okay, so this is what we are going to take place. And in this case now, where the oxygen will take the electrons, from this carbon or from this carbon? Obviously, it will take from the first carbon. Why from the first carbon? Because you are going to get a benzyl cation. What we are going to call it as benzylic cation. You are going to get what? Benzylic cation. which is resonance stabilized, which is resonance stabilized, which is resonance stabilized. I already told you benzene with primary and secondary carbons are there. Those all are benzylic cation formation which are resonance stabilized. So this is more stable one. So oxygen will take electrons from first carbon for the formation of benzylic cation. So the what is the product here? pH CH2X plus OCH3, that is CH3OH. I hope you guys understand this one. Correct? I hope you guys understand this one. Right. Okay, so this is very, very most important and most prominent one. Okay, so some of the questions I will give you and you try to solve them and then we will wind up our class here. Okay, some of the question I am giving here, pH, O, CH3, if I am giving HX, what is the product? And it's question number 1, this is question number 2, pH, O, CH3, if I am giving excess of HX, this is minimum HX and what will be the product? Okay. Next question number 3, pH, CH2O, CH3, excess of HX if I am giving, what is the product? So these are the questions, guys. That's it. Our chapter has been finished, and we know that there are some of the reactions, bromination for the enizole, and you will have a para and ortho one, and nitration is also there. That is one, and Friedel-Crafts alkylation is there. Okay, Friedel-Crafts alkylation, Friedel-Crafts acylation is there. Okay, and rest of the things is common. Okay, so our chapter has been finished. So homework is, first one is bromination, you people need to check bromination. Second one nitration, and third one Friedel-Crafts acylation and Friedel-Crafts alkylation, and rest of the things are done. Okay, that's it, guys. Thank you so much for joining the class. Please do the questions and never waste time. Okay, very best for your examinations, for the practicals. Okay, probably from the next week I'm not going to take your classes. You are going to get a new enabled teachers, so they are going to teach you for sure. Okay, guys, see you in the next class. Bye.